module 13.4, spatial factorings. So these type of problems in this particular section is basically the same thing as when we did the spatial product, but now we're going to look at them from the other perspective. Rather than multiply them, we're going to divide them, or we're going to learn how to factor them. So here are your perfect square numbers, okay, 1 squared all the way to 20 squared, okay. So by knowing these perfect square number, it does kind of help us to recognize differences square. So as you can recall, differences square, we call them differences square is because it's a subtraction between two perfectly square terms. As a matter of fact, differences square is referring to two terms, okay? Both terms are perfect square and they have opposite sign, one positive, one negative. So when you see a problem like that, okay, then we can just write our answer as a plus b times a minus b. All right, so I mentioned before, you got to know what was your a before it was squared when we did when we first learned how to find the when we first learned how to do the how to do the difference squared by multiplying them. So here we will use the same concept. So 25x squared minus 9 squared. This is called difference squared. I see a subtraction between two perfect square terms. So if I just follow my formula, this is a squared minus b squared. My answer should look like a plus b times a minus b. So what was my a? Okay, so the question is, what was my a before it was squared? So my first term is already squared. So what was 25 before it was squared? It must be 5. What was x squared before it was squared? It must be x. So my a is really 5x. Plus my b, what was my 9 before it was ever squared? It must be 3. So my answer would just be 5x plus 3 times 5x minus 3. So that's a difference of squares. Okay, I'm going to jump to this one. This is not a difference of square because this is actually addition between two perfect square terms. Sometimes, if you ever seen this, something called the sum of two squares. If you ever heard of this, sum of two squares. If you ever heard of this, please ignore that. No such thing as called sum of two squares. No such thing as that because there's no factoring problem that's called sum of two squares. So even though both terms are perfect square, because this is an addition sign, that means this problem is actually not factorable. It's not any one of the 6 type that I wrote down in the previous lecture videos. Okay, so this is not factorable. All right, no such thing as sum of two squares. Okay. All right, take a look at this one. 9y squared minus 4x squared. So whenever you see two perfect square terms with a subtraction sign in the middle, that is the difference of square type of factoring problem. So this particular problem, I'm using two different variables, y first and x next. So let's think about this. Okay, what was my 9 before it was squared? It must be 3. What was my y before it was squared? It must be y. So my answer needs to look like a plus b times a minus b. So my a is 3y. My b before 4 was squared must be 2. Before x squared must be x. So my a is 3y, my b is 2x. So my answer is 3y plus 2x times 3y minus 2x. And I normally put the plus in the front, minus in the back. You can have them reversed, that's okay. Okay, the answer is still the same. All right. Now, never forget, when it comes to factoring, you always got to look for greatest common factor. So right now, this problem does not look like a difference of square, okay, because I do have a greatest common factor between the two terms. I believe I can factor out a 5. So if I factor out a 5, that should give me 4x squared minus 9. So, like I mentioned before, the way how we check the answer is always check what's inside the parenthesis. So inside the parenthesis, I see this is a difference of squares. Okay, so I can factor again. So before 4x squared was ever squared, it must be 2x. Before 9 was ever squared, it must be 3. So my answer, 5 times 2x plus 3 times 2x minus 3. Okay, all right, so just a quick example. quick few example on how to factoring different squares. Okay, let me write one more down. Very tricky. Couple example here, very tricky. X squared minus 1 is one of the hardest one to recognize. This is a difference of square because 1 is actually always squared. So if you ever seen x squared minus 1, this is a difference of square where before x was ever squared, before x squared was squared, it must be x. Before 1 was ever squared, it must be 1. So this is going to be x plus 1 times x minus 1. All right. Another one is hard to recognize is 9x squared minus 36. Using 9 and 36, that's kind of hard to recognize because by first looking at it, both of these terms are perfectly squared, right? 36 is 6 squared, 9 is 3 squared. But there is actually a greatest common factor between the two terms, which is actually 9 itself. So we actually need to factor out the 9 and say this is x squared minus 4. So if I now check what's inside the parenthesis, this is another difference of square. So I can factor again. So that will actually be 9 times x plus 2, right? Before x squared was squared, it was x. Before 4 was squared, it must be 2 times x minus 2. Alrighty. So so with this problem, we will conclude this lecture video on how to factor difference of squares. Thank you for watching.